stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause the stream is about to start. Get ready wherever you are, 'cause the stream is about to start. Hello everyone and welcome to day 4 of Advent of Code. And tonight with me I have David. Hello, what's up? And I also have a new guest. Hello, introduce yourself.
Hi, my name is Star. I produce electronic music and I'm trying to learn how to code music stuff.
Ah, that's fascinating. And have you done the other challenges in the Advent of Code so far?
I have not. I'm joining late.
Okay, well, you are in for a treat. I'm hoping that you have a good time today. So, let's first discuss the idea I had. I was teasing it yesterday, and my idea was to use a programming language that is kind of fun to use. It is a programming language that is Brazilian, which I was born in Brazil, and David is, let's say, half Brazilian. And it is a programming language that I learned because of some music software. Do you use Reaper, or have you heard of Reaper?
In fact, I think you answered a couple of my questions that I posted in the Discord.
Well, there you go. There you go. I'm probably just not connecting the dots because we often go by different names in different places. But yeah, so there is this programming language called Lua. Have you used Lua before, David?
No.
Have you heard of it?
No, I don't think I ever have. Is it? I'm maybe getting it confused with Julia. Is Julia the statistics one, and then Lua is something else?
Lua is something else.
Okay.
And have you used Lua, Star?
I last used Lua, I think probably about 8 years ago or so to make a mod for AudioSurf 2.
I see. Well, Lua is not a language that changes a lot. Unlike other languages like JavaScript, which you see updates for JavaScript every year, and even C++, a more traditional language, is going in that route as well. Lua is very stable, and there are some new versions. They are not released often, and they don't change much about the language, so you will probably feel familiar. So are you all comfortable trying out Lua tonight?
Oh,
Definitely.
sure.
All right, so let's go for it. And geez, yikes, my camera on Skype, it just stopped working. Hang on.
Yeah, it looked better before.
I guess it's one of those things. I'll try turning it off and on again. How about that? So, yeah, I learned about Lua because it's a programming language that you can use to script and automate things in Reaper. Also in Hammerspoon, which is an automation tool for Mac OS. So, for instance, when I am starting a stream, I press a key combination and it does everything that I need, from setting up the camera to setting up OBS and all of that. I automated that in Lua in Hammerspoon. And it is a language that is meant to be small in the sense that you embed Lua in your software. That's why Hammerspoon, Reaper, World of Warcraft, many other games embed Lua as a scripting language. It's much smaller than something like JavaScript, but it gives you all the freedom and the flavor of a dynamically typed programming language like JavaScript. And there are some very elegant bits about the design, which I'm sure are going to come up as we solve the problem. So how about we just get started? Do you want to dive in?
Let's do it.
All right. So we are now going for problem number 4. And problem number 4 is scratch cards. The gondola takes you up. Yeah, so Star is joining us now, and you haven't done the previous problems. So it's a programming puzzle, but it comes with a cutesy story, and we are going up in a gondola to find a source of water. And as we solve the puzzles, we get stars for our little Christmas tree here. Or I'm not sure it's going to be a Christmas tree, but we are getting the stars for something that is going to build up as the month progresses. Strangely, though, the ground doesn't seem to be coming with you. You are not climbing a mountain. As the circle of Snow Island recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of the new island and lurches into the station. As you exit the gondola, the first thing you notice is that the air here is much warmer than it was on Snow Island. It's also quite humid. Is this where the water source is? The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colorful square cards. Oh, hello! The elf excitedly runs over to you. How may I be of service? You ask about water sources. I'm not sure. I just operate the gondola lift. That does sound like something you would have, though. This is Island after all. I bet the gardener would know. He's on a different island, though. The small kind surrounded by water, not the floating kind. We really need to come up with a better naming scheme. Tell you what, if you can help me with something quick, I'll let you borrow my boat and you can go visit the gardener. I got all those scratch cards as a gift, but I can figure out what I've won. You know, when I was a kid, there was this scratch card that it was not just one prize. You had to scratch just certain parts of it, and if you got the right parts, you would win the prize. But I was a kid and I didn't know, so I scratched the right parts and I won, and then I scratched the rest anyway. I completely clueless about the rules of the game, and for some reason this stuck with me. The elf leads you over to the pile of colorful cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. Picking one up, it looks like each card has 2 lists of numbers separated by a vertical bar. A list of winning numbers and then a list of numbers you have. You organize the information into a table, your puzzle input. Boop. As far as the elf has been able to figure out, you have to figure out, that's awkward phrasing, which of the numbers you have appear in the list of winning numbers. The first match makes the card worth 1 point, and each match after the first doubles the point value of the card. In the above example, card 1 has 5 winning numbers, those 5, and 8 numbers you have, those 8. Of the numbers you have, 4 of them are winning numbers. So let's check. 48, for instance. I have 48, and it is a winning number. I have 83, and it is a winning number. And I have, well, and so on. 17 and 86. So 17, 17, 86, 86. And importantly, 6, 31, 9, and 53 are not winning numbers. Of the numbers you have, 4 of them are winning numbers. That means card 1 is worth 8 points. 1 for the first match, then double 3 times for each of the 3 matches after the first. So the first match, let's say, is 48, and then times 2 is 2, times 2 is 4, times 2 is 8. Okay. Card 2 has 2 winning numbers. Card 3 has 2 winning numbers. Card 1 has 1 winning number, and so on and so forth. So in this example, the elf's pile of scratch cards is worth 13 points, which is the sum of 8, 2, that's 10, 2, that's 12, 1, that's 13, and these don't have points, so in the end, 13. Take a seat in the large pile of colorful cards. How many points are they worth in total? Let's just take a quick look at the inputs to see if there are any peekaboos, like negative numbers or whatever. It seems
We certainly already learned the trick about line numbers and not trying to parse the card ID.
True, we can do that. We can rely on the fact that the card ID is sequential and not skipping. We can rely on the fact that numbers are 2 characters at most.
Yep.
We can rely on the spacing. We can rely on the pipes. This seems like a perfect problem for something like Lua, which none of us is very good at. I'm at least not very good in Lua. So yeah, let's get started, and I will create here.
Any provisions or crystal balls about what the part 2 will be?
It's funny to take a guess, so I am going to.
So just to explain to Star, each problem has a part 1 and a part 2, and if you go too far down one solution with part 1, you might have to rewrite it for part 2, which is what happened to us yesterday.
But David didn't let go. He, after the stream, re-implemented the thing using another idea. He wanted to see every possible way of solving the problem.
Well, it was kind of what I initially thought, and I just wanted to see if it made any sense. But it was not a terribly elegant implementation. But yeah, I have no idea what the part 2 will be for this. I can't think.
I think that, well, there are 2 significant parts here. The first is containment to determine winning numbers, and the second is how to compute the points. Computing the points is suspiciously powers of 2. So maybe that will get a bit more complicated, but then again, it may be something like related not only to the fact that 83 is a winning number, but also something about the number itself. Like maybe you start multiplying the winning numbers, you do some more computation to determine the points, not just powers of 2.
Yeah, I'm going to say that you concatenate the numbers and then you just add them up rather than, I don't know, it's not exactly more complicated.
Yeah, that doesn't make a lot more, doesn't make it a lot more complicated. I don't know.
No.
That's interesting. It almost resembles the type of thing that I'm working on for a microtonal plugin in Reaper, where
so you are that person.
I am, yes. Yeah, so I actually do have this challenge of representing data that I don't know what might be done with it next, and so numbers to be stored as text or as numbers, or as MIDI data, and I've also flipped through those different options of storing it in different ways to try to figure out what's actually going to be the most flexible to extend to different use cases. In some ways, I don't know my own part 2 yet. I have an idea of what it might be, but yeah.
You see, yesterday we were looking at, after we solve the puzzle, we often go to the subreddit to see what other people are doing. And there was this person doing it with Vim, the text editor. So it's not that the person was using the text editor to edit the source code for the solution. No, they were using Vim as the tool for programming. So you would create keyboard shortcuts and stuff like that. And what was interesting about that solution is that there was a grid in which you had to mark certain numbers because they had a special meaning. And I found so clever that the person wanted to mark the numbers, but they didn't have a convenient way of doing that. So they converted numbers into letters, lowercase letters, because then marking a number as special meant capitalizing the letter. So it meant like essentially coloring the numbers in a special way by converting them into characters and then using uppercase characters to mark them. Thought that was really smart. Anyhow, so I have shared in the Skype chat here a link that you can use to join a live share. So you will be able to see what I'm typing and you'll be able to type with me, which will come in handy. So this is going to be 4.lua. And I will start by getting this as our input. Then, oh, and I didn't mention this, but there are many ways of running Lua. Like I said, it's embedded in many pieces of software. For convenience, I am going to use Hammerspoon as my way of running Lua. And yeah, if you're following along and you don't use macOS, you can use probably any Lua interpreter, including Reaper, and it will probably give you the same output. All right, first task. We need to split this in new lines so that we get each of the cards. And already, we are Googling this because I don't know how to split a string.
Copilot.
Or that, yeah, please, go ahead. Ah, that's cute. So already, at least on this answer that I found here in Stack Overflow, which I will share with you on the stream as well. Already this solution is showing us two interesting things about Lua. The first is that the library that comes with Lua, so the library that includes string manipulation and numbers and that sort of thing, it is serviceable, but it's not super extensive. For instance, it does not provide us with a split function to which we could just pass a character or maybe a regular expression and it would split on those. No. It does provide us as a thing that does matching, but it's not with regular expressions. It is with what's called a Lua pattern, which in some ways resembles a regular expression, but it is more limited and it uses a slightly different syntax. The reason for the different syntax is probably to not confuse people who already know regular expressions and have some expectations about how they should behave. But the reason why it is limited in features is because Lua is a small language, and some regular expression features are very powerful. We have seen yesterday that you can use a relatively straightforward regular expression with back references to determine if a number is prime. So the regular expression engine that runs the regular expression needs to factor a number, right? It's complicated stuff. Lua patterns are more limited in their feature set because they are like simpler conceptually, even simpler to implement. Cool. So what we want is not to split on the new line. Instead, what we want is to do a global match on anything, any sequence that does not include a new line.
I think I've done that.
Oh, I need to accept. Okay, I see your cursor there. Excellent. So splitting into new lines. Oh, and local is a keyword that you almost always want to use in Lua, because if you don't say local, then it becomes a global variable. But since
global would be fine in this case. I was going to say global would be fine in this case.
Not only global is fine in this case, but there are some quirks about the way that I'm going to run Lua, because like I said, I'm going to be using Hammerspoon, which is, well, I guess the icon has been swallowed. It's this guy. And I'm going to open the console. And there is a quirk about the way that local variables work in the console here in Hammerspoon, which means that I'm not sure I will be able to use local variables. Let's see. Local hello equals star. Oh, I said star and I wrote start. And hello, it's new. See, yeah, in the
Wow.
way that Hammerspoon runs, it interprets each line as if it was a whole program, which may be okay if you just copy and paste from here. But just to make things easier, I will make every variable global, like so, and then it is available like that.
Okay.
All right. So let's see. I'm going to remove the locals from there.
Mm-hmm.
And this is something interesting. It is a data structure called a Lua table. And
Okay.
it happens to be the only data structure in the language. In other languages, you would have your arrays, your maps, your hashes, your associative arrays, your sets, and your this, and your that. No, in Lua, the only data structure is a table. A table is, let's say, a map of keys into values, and that's all. So if you want something like an array, you make sure that the keys are sequential numbers, 0, 1, 2, 3, and so on. But except that in Lua, we don't count from 0. We count like normal human beings. We count from 1. So Lua tables, when used as lists or arrays or however you want to call them, start counting with 1. Then
Yeah,
if
it's
you...
not.
So, go ahead.
I was going to say it's not too dissimilar to how JavaScript arrays work.
True.
Because you know the concept of sparse arrays, so you can just index into any
True.
index of any JavaScript array, and it will just create it. It becomes like de-optimized probably, like depending on the engine or whatever, but it's somewhat similar. But it's cool that this is the only data structure that they have, I guess, apart from primitives.
Well, a number or a string, well, I guess you could say that a C string is kind of a data structure because it's a list with an end character. But anyway, yeah, it's you have numbers, you have strings, and so on. But I would say that the only non-atomic data structure is a table. And if you wanted, for instance, a set, you can use the keys of the table to store elements, and the keys of the table must be unique. So you end up having a set. And yeah, and of course, if you want something like a JavaScript object, you just use a table as pretty much a table. With the caveat that Lua tables can have any data type as the keys. That's how you use them as sets, for instance. But in JavaScript, in an object, the keys must be strings.
I guess the conclusion from that is like the only data structure you need is an ordered dictionary. Like you never really need to use arrays or sets, or
I'm not sure if the elements are ordered.
Where do you mean? Sorry,
In tables in Lua, I'm not sure if the
really?
elements are ordered. I know that when we are going to traverse the table, we will be able to say if you want to see the elements in order or not, but I'm not sure if it's in the order of insertion or if it's just going to see indices like 0, 1, 2, 3, and so on.
Okay.
Still there, Star? Okay, you are.
Oh,
okay, so let's read over what's happening here. We have our lines table, and for each line on the input matching, so this is a Lua pattern, and it is very similar to a regular expression, but it isn't. We have to keep that in mind. This probably will come up soon enough, and it's matching anything that is not a new line multiple times. And then it is using this auxiliary, let's say, library that comes with Lua, and you can do insertions on tables, and it will compute the index of the next sequential number. So you can pretend that a table is like an array. And we are adding our line into our lines. And then we are splitting on this, and we are splitting on that, it says. So what is happening here? The line is matching a card and then capture group of digit plus and then space and then capture group of the rest, and then it's nums.
Yeah, it might not be what we want actually.
Well, I kind of like that, and I think that it actually subsumes doing this. We don't need that, right? We will have access to our card number, and we will have access to our numbers right then and there. And I would say so far the card number hasn't been necessary. Am I right about this? We will not use it.
True.
We will just use the numbers here, the numbers there.
Maybe that's what part 2 is about.
Maybe.
But yeah, that's fair.
I think we can do one extra step here and do... So we are not really interested in this. I'll take out this capture group. Then I will do this to get us this sequence. And then I will do the pipe here.
It still kind of blows my head how regexes work, that they're able to continue capturing as much as possible, but then still account for the you're saying, with the star, you're like, take as many characters as possible, but then surely that also includes the pipe. It kind of, how does it, do you know what I mean?
I know what you mean. And I think we really need to write a regular expression engine.
That's true.
Yeah. And just roughly speaking, so you're not left in the dark, the way that this is going to work in a regular expression engine, or I guess in the Lua pattern engine, is that it is going to get here and it's going to say, okay, I want to match anything dot, any number of times star, and I will do that, but I am also looking for this space pipe space thing. So I will be going like, have I reached space pipe space? No. Okay, so I'm gonna consume that. Have I reached space pipe? Oh no, I have not. Okay. Okay. So you at this point you have an option. You can either continue capturing here in this dot star, or you can go to the next part. Of course, in this case, you only have to do this once. So once you see space pipe space, you can move on from this to that. But more generally, you may need to keep multiple states in your hand and juggle them. Like, okay, maybe I found my space pipe space, or maybe I need to keep consuming here because there will be something else further down the line that will invalidate me. So I cannot do this eagerly. I cannot just consume everything and forget about the past.
Yeah.
So that's why a regular expression engine can sometimes be exponential depending on the regular expression. Anyhow, I have this memory, this vague recollection that dot star is not how you say anything in Lua patterns. So I will briefly consult the Lua book, Programming in Lua. There is a newer version of the book, but this relatively old version is still good because Lua doesn't change all that much from 5.0 to 5.3. And it's an awesome book, by the way. I love it. And I may be misremembering because the star seems to be 0 or more repetitions. I'm curious if the dot is probably anything. So yeah, I think I am misremembering. Anyway.
Okay.
So here are our winning numbers, and here are our numbers. How do they call that in the challenge? Yeah, the numbers you have. So I'll just call it our numbers. And now let's see if this is already working or if there is a problem.
There might be, I don't know if like the new lines at the end and the beginning, whether that's going to be an issue.
Well,
but we'll see.
Here's something we can do real quick. Hammerspoon comes with a set of tools to help you write Lua, and this part will not work in Reaper, for instance, but it does come with this inspect thing, which will print the string. I guess I should say just input here, and it will print the string for us, and and it will not just print like this. It will put the quotes, so we'll be able to see what's happening with the spaces. Right. So But it used the same syntax to print. That's cute, right? Oh, no. I need to say print specifically? No, I don't. So what's up with that?
Oh, that was just your input, yeah.
Yeah, now it printed. So why not the input?
Well, input's global, so you don't need to paste it again.
True, that was the problem. So it seems like in the beginning... Oh, and this is syntax, by the way, for multi-line strings in Lua. And in the beginning, the space is ignored. In the end, it isn't. But I think this will do the right thing because there is nothing after here. So we are not really splitting. It's not like there will be an empty element in the end. What we are doing is matching this, then matching that, and so on. So I think it should be fine, but let's, I don't know. Let's see.
Yeah.
So I guess I will print my winning numbers, for instance. I shouldn't be copying the whole thing, I know. And no.
Looks good. Well,
my winning numbers are this. And I am printing our numbers. So maybe there is not an underscore here because I removed the capture group from there.
Oh, yeah, of course, yeah.
Of course. So, all right, that's correct.
Yep.
Now, I guess should call this the print numbers string and our numbers string. Because we don't have the numbers yet. So let's find a way to get, let's say, a set of winning numbers. So I will want to split the winning numbers string on the spaces, which we know now means gmatch.
Should I do it?
Uh-huh. So now we have a set of winning numbers. For number in winning numbers, gmatch that looks right. Do table insert of winning numbers to number of number. That's not exactly what I wanted because it's exactly what you asked for, but this is a list and I was thinking of a set. I will change this by hand. Here's how it goes.
Okay.
I will say winning numbers at this number, and the value can be really anything, but I will put true in there. Okay.
Oh yeah, I see.
So now I'm using the winning numbers table, but I'm using it as a set because I am setting my values on the keys, and the value can be anything. And we can do the same for our numbers, yes. But we can do a shorthand, and I did the winning numbers first for a reason, because once we have done the conversion here, we can check right away if my winning numbers at that, then I can have something like winning or a counter for how many numbers of our numbers are winning numbers. How do I call this? I'll call it banana because I'm blanking on a good name. And or maybe even better. No, I have to do it this way. And then by the end, here, I will take our score and I will add, how do I do powers? Well, it's going to be 2 to the power of banana, and I will want to have a score of 0 in the top and print the score at the end. I misspelled banana.
Apparently it's the carrot. but I don't know.
Looks good to me. So, I want a better name for the banana. Number of winning numbers that we currently have in our numbers. How about that? You know,
terrible.
In the subreddit for Advent of Code, there is like this theme, and every day there is a different ingredient, and then you have to use that ingredient in your program to make it as funny and or ridiculous as possible. For instance, yesterday it was spam, and then people wrote these huge programs in which the variable names all looked like this, and they all had to do with spam and other Monty Python references. Anyway,
we have winning numbers. We have our numbers, so we could have our winning numbers, and then it could be our winning numbers count.
There. Let's reread this real quick to see if there is anything that stands out as obviously wrong.
Looks good to me.
You may have noticed that in Lua there is no plus equals and there is no plus plus. So you have to spell it out, and it is by design.
I'm fine with that.
Huh?
I'm fine with that.
Yep, it is by design, and the creators of Lua said like, yeah, we could do that, but it would make programs harder to read, so we won't. And there, have at it.
I think they actually removed that from Swift.
Really?
I think it was a feature, and then they actually deprecated it and removed it. The plus plus.
Wow, that's such a bold move. To never have it is already a bold move, but to remove it? Wow, I love it.
I'll have to verify that.
Okay, I like everything I see. Yeah, I will copy, I will paste, I will run, and it will fail. Attempt to call a new value, but that's okay. That's just a typo. And we got a number, 28. What is the answer? It's 13. So, no, that doesn't seem right. Oh, really? We have to start, if you have like 0 matches, we shouldn't be adding anything, but the way that we are doing it, we are adding 1. So that's a mistake already. We should start at like -1 and count up, but we should only add to the score if the count is greater than 0.
Um,
12. Still not there.
I think, is it that it needs to be 2? It was correct before, but it just needs to be 2 to the hour winning numbers count -1. Because like the first one is not. Like if you have a count of 3 or a count of 2, that means the first one is just 1. So it should be 2 to the 0 plus 2 to the 1.
Now I got it right,
what I mean?
and I see what you mean. Maybe not. Now the program is outputting the right thing. The problem was greater than or equals. But can you say that again, please?
Well, I was thinking it just needs it's just like an off by 1 thing, because if it's 2 to the if you have just 1 count, then it's plus 2 to the 0.
Which is 1 point. 2 to the 0 is 1.
Yeah. So I'm just thinking whether you could have had it how you had it before, but just do our winning numbers underscore count -1.
Yeah, if you wish.
And then you can get rid of the if.
No, that you
Do
cannot.
you still need No?
No, you cannot, because think about it. If you do like this, then think of the case in which there are no winning numbers. We are going to end up with a 0, and this is going to end up being a -1. 2 to the -1 is half, and you don't want that.
Yeah.
You want to add 0 in that case. To add 0 to that case, you can either do an if, and in this case, it needs to be greater than or equal to 0, or you can use a ternary operator, which is a feature that Lua doesn't have. You know, in languages like C, JavaScript, Java, and so forth, you can do like condition, question mark, then the then value, and the else value. In Lua, they don't have that, and that's by design, again, to make things simpler. But you can do something like this: condition and then value or else value, because the result of and or are not booleans. The result of condition and then value is going to be either condition if it's true-ish, or then value if it is true-ish. And the result of something or something else is going to be one of these as well. So we could simplify this code and put it in one line by doing a whole lot of stuff there, but I won't.
No, I get that.
And I suppose that with this modification, the result is, it's not. I was going to say
it's because you changed it should be greater than or equal to 1.
There. Yeah, and I preferred this version because really the count of winning numbers is more accurate if we write it this way. Okay, I love it. So I will run now with the whole input. Oops.
It's funny. I did some Advent of Code last year, or some year, maybe not last year, and I did it in Swift, and I was pasting all the strings at the top because I didn't really know how to read from a file, and I was like, I'm such a noob. I should just learn how to read from a file. But actually, in some ways it's much easier, isn't it?
Doing what we are doing here is easier in some ways.
Yeah.
But it is also more difficult in other ways. You have to copy and paste more, but what I was going to say is even more interesting. Watch. In Lua, the language itself, there is no concept of a file system, and there is no concept of like properly like reading files. And that's because Lua can be run in a system in which there is no file system. Like it could run it embedded in something. So there are some like facilities for manipulating file descriptors, but the file descriptors may be like not even in a file system, so to speak. So there is something like that amounts to fopen. I think it's even called fopen, but it doesn't have anything like what is the separator for directories in this operating system. Is it / or \? Are we on Unix or are we on Windows? It doesn't even have that kind of concept. And of course, in the software that is embedding Lua, often you will find these facilities. Like for instance, in Hammerspoon, you will find lots of stuff like the inspect thing, but the language itself doesn't come with assumptions about its environment in that way. I think it's really cool. And the problem now that we are facing is that there are more cards, so there are more spaces there. So let's change this Lua pattern real quick to not embed the space here, but have like that. And then this is like one or more spaces. And I think
could we just get rid of the card part of it?
You are right that we could just use the column as a separator, right? How about that? Well, we got our result. Yes!
Yay!
We did it!
Now, how the hell am I going to run Lua to get my result?
Well, I'm sure there is some interpreter for Lua online.
Yeah, it's probably a REPL. I can also just rewrite it in a language I can run it as well. It wouldn't take long.
Oh, there you go, from lua.org.
Oh, nice. Oh, yeah, I'm sure there are because it's so embeddable, right?
Oh, it's a long string.
Yeah, sorry I wasn't able to contribute anything. I did follow along with just running the code in Reaper, and I was happy to see that. I mean, it worked there too, so no surprise there. But I all I had to do was change the print to Reaper show console message, and that was mine.
And if you just print,
Mhm.
it does show up somewhere. I think I'm fairly sure that it shows
it'll
up
show up in the-
somewhere.
Yeah, there's the variables watch window on the left, so I think it will probably show up there, even if I didn't print it at all.
Ah, there you go. Yeah, very cool, very
I
cool.
really
So
don't like.
what?
I
As
You
far
don't
as the
like?
re- As far as the regex goes, this reminds me that every time I have to do something like that, I always have to look up the syntax. And I did an interesting one in Reaper recently with EEL2 or JSFX, where, well, specifically EEL2, because there's no API function for reading the lane names, the new feature in Reaper 7, which I wanted to be able to read and write to, and so I wrote like a really complicated match function that loads the entire Reaper project file into a string, then finds the selected track from its GUI ID, and then looks for the whatever the word identifier is, because it's just a plain text file, and parses the lane names from that. So that was just a lot of trial and error, having to sort of compile the match string from different pieces, and yeah, it was guess and check pretty much for me. So that I didn't really have.
There is something that
may.
may simplify things for you ever so slightly.
Yeah.
You can, using the Reaper API, get what is called the chunk for the selected track. So you can get a hold of the track, and then you can get what's called the chunk. And the chunk is literally the piece of text that represents that track in the Reaper file. So at least that much of parsing or that much of text manipulation you can get rid of by getting the chunk. But then from the chunk, it's just a piece of text, and you can continue doing what you are already doing to work with the lanes.
That's genius. Thank you so much. That will simplify things.
Yeah, you can do that with most, let's say, entities in Reaper. You can get the chunk of a track, you can get the chunk of an item, you can get the chunk of, I think, takes, and that sort of thing. Anyway.
Very cool. Okay.
Yeah. Alrighty. So, who is ready for part 2?
Oh yeah. And just a thought. I was thinking for a second. It would be nice if we could initialize the value of, just to get rid of that if we could have it as a value which by default would be 2 to the power of it would result in 0. And then I was like, well, what is that number? Because obviously it can't be 0, because then it would be 1, and -1 would be a half. So, and 1 would be 2. So it's like I guess this is some mathematical, like known thing, right?
It is, and I will show you the answer to that. It's really cool. So you want something 2 to the power of x,
Yeah.
and you want the result of that to be 0, right?
Mm-hmm.
So yeah, let's just go there. How do I pan on this thing? How do I move? Yeah, there. It's right there. Of course, it looks like it's 0. It isn't 0. Not yet. If you zoom in enough, you'll see that we are not at 0 there. We are still like ever so slightly off. So let's continue.
Yeah. We'll get there.
You get there. Yeah, that's 0. That's 2 to the power of minus infinity if you take it to the
Yeah.
limit. For the mathematicians out there, if you take x to the limit, okay? I said it. Yeah, so you said that you were following along and you were copying and pasting, but is there anything that stands out, like what the hell just happened here?
I don't think so. I think it's mostly just a matter of getting familiar with the Lua syntax for me.
Got it. Okay. And I suppose that Gmatch and Lua patterns are your best friends at this point, right?
Not quite.
Have you used tables?
A little bit, but I remember being confused by them last time I tried to do something
Mm,
like table specific. I think it might have been. I don't remember what the use case was,
okay,
but so far so good.
fair enough.
I
Fair
think
enough.
from if it was like 2D arrays, then I would probably be thrown off.
Tables of tables. All right. Yeah. I tend to use tables a lot because the way that I write my Reaper scripts tends to be first I will do all the chunking, all the getting items, and all of the like extracting the information I need. Then I will compute the actions that I need to run. And then I will run them, blah, 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 which makes some things easier. For instance, dealing with undo can be tricky, but if you do it like in collect, and then run everything at once, then undo becomes slightly more straightforward, because it will never be the case that you're running and then you realize that, oh, but there is this edge case and I need to abort, and then you leave the undo state all messed up. So I end up using a lot of tables in my scripts because I am collecting all this information that I will need to work on later. All right, let's do part 2, my friends. Just as you are about to report your findings to the elf, one of you, hang on. In the story, are we a party? Anyway, one
We're
of you.
with the other elf,
Ah,
maybe.
yeah, you are with one elf, right?
Yeah.
Okay. One of you realizes that the rules have actually been printed on the back of every card this whole time. There is no such thing as points. Instead, scratch cards only cause you to win more scratch cards, equal to the number of winning numbers you have. Specifically, you win copies of the scratch cards below the winning card, equal to the number of matches. So, if card 10 were to have 5 matching numbers, you would win 1 copy each of cards 11, 12, 13, 14, and 15. Copies of scratch cards are scored like normal scratch cards and have the same card number as the card they copied. Wait, what?
I'm not following this.
I'm not following this. So maybe the example will help.
It always becomes obvious when they do the examples, though.
Yeah. So if you win a copy of card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original card 10 won. Cards 11, 12, 13, 14, and 15. This process repeats until none of the copies cause you to win any more cards. Cards will never make you a copy of a card past the end of the table. Jeez Louise. This time, the above example goes differently. Card 1 has 4 matching numbers. Okay, so far so good. So you win 1 copy each of the next 4 cards, 2, 3, 4, and 5. Your original card 2 has 2 matching numbers, so you win 1 copy of the cards 3 and 4.
Sorry, you win. What does it mean by a copy?
I suppose there is like now... the way
So
I'm
you kind of accumulate copies or something? Accumulate cards, which can be...
Good point. Like, for instance, we are winning card 3 twice. Does that count as just we won card 3, or does it count twice because we won it twice? I guess the question here in the end is how many total scratch cards do you end up with? So I think that the card 3 counts twice.
Okay.
So
yeah.
And because we have 2 copies of card 3, then I suppose when you play card 3, you play it twice.
Right.
So it's gonna go and you're gonna end up with a lot of cards, I think. Okay, your copy of card 2 also wins 1 copy each of cards 3 and 4. See? we had an original card 2, but the copy also counts. So we played card 2 twice, so to speak.
Mm-hmm.
I'm pretty sure
Yeah,
that
this is
combine this with like the powers of 2s, and there is something very mathematically pleasing about this somewhere. Anyway,
Yeah.
you are 4 instances of card 3, 1 original and 3 copies. The 3 copies come from here, from there, and from your copy of card 2. Okay. Have 2 matching numbers, so you win 4 copies of each of cards 4 and 5, because there are 2 matching numbers in 4. Yeah, 2 matching numbers, so you win card 4 and 5, and there are 4 instances, so you win 4 copies. Oh wow. Your 8 instances of card 4, 1 original and 7 copies, I'm not even tracking anymore where the copies came from, have 1 matching number, so you win 8 copies of card 5. Your 14 instances of card 5, 1 original and 13 copies, have no matching numbers and win no more cards. And your 1 instance of card 6, the original, has no matching numbers and wins no more cards. Easy peasy. Once all the originals and copies have been processed, you end up with 1 instance of card 1, 2 instances of card 2, 4 instances of card 3, 8 instances of card 4, 14 instances of card 5, and 1 instance of card 6. In total, this example pile of scratch cards causes you to ultimately have 30 scratch cards. Process all of the original and copy scratch cards until no more scratch cards are won, including the original set of scratch cards. How many total scratch cards do you end up with? I just love this.
That's a lot of scratch cards in one sentence.
Okay, I think that this warrants like stopping for a second and thinking before writing any code.
Yeah. Star, do you have any intuitions, instincts about how to do this?
I just started kind of writing some code, so maybe that's not the right thing. I should pause and think more. But my thought was, I guess, more of a less mathematical thing to just do the first pass as before, but make another table that keeps track of which lines, like the number of things, points per line, and then to do something with that. But that's all the further I got. So kind of accumulating the number of wins per pass, but then like how do you, does that end up being like a recursive call or something? There might be some recursion in here, huh?
Yeah, I think I had a pretty similar idea where, do 2 passes. One, which we've already done, and keep track of all of those numbers, and then iterate through that array, and then like for each one, sort of populate a new table in Lua speak, which we sort of feed through the counts going forward, if you see what I mean. So there's like this secondary table which builds up the true result. Let me just sum it up at the end.
Now, would you sort of, since you never need to go backward to process a previously won line, because line 2 can never win line 1 again. So maybe is the first pass sort of like, do you do the second pass at the end of the first pass type of thing? Like process?
Yeah, you could probably do it. Probably Leandro will find a way of doing this inline, because that's his specialty. But I would do it in 2 phases because it's easier for me to reason about. So I do one and then I do the other. But...
I see. Well, here are some thoughts.
Sure.
When we are doing the example, we do 1 pass. We just go over card 1 and we determine the matching numbers. And then we annotate on the side. There is like a little table on the side, to use some Lua speak. There is a table on the side that, okay, how many cards 2, 3, 4, and 5 I have? Well, to begin with, I had 1. But now I'm going to take note on the side that now I have 2. And then I move on to card 2. And then I do it. And then I take note on the side. Oh, okay, now I got one more of 3 and 4. So I just keep this side table with the number of cards that I have accumulated. But I can do this in one pass. I never have to backtrack because I never go up. It's never the case that card 4 is going to give me copies of card 3 and 2 that I need to rerun.
Yep.
So my idea is to actually keep... I think that this time the solution for number 1 will head us in the right direction, because I think we can keep the bulk of the parsing and the structure of the program. Really, the trick is now, what do we do when we get here? Or actually when we get here, because we are not just counting up. Now we are taking notes on the side table and pretty much that. We are just taking note on this side table. When we get to the end, the side table has the number of copies of each card. So we just have to sum everything up and print it. So, and of course we need to be smart about removing stuff at the end, because if card 6 had 3 winning numbers, then perhaps we would count as having copies of card 7, 8, and 9, but we don't have card 7, 8, and 9, so we have to prune at the end and clean things up. But in principle, it seems like this could work. How does that sound?
So, yeah, I guess it's for J in I to I plus count. If you see what I mean.
What?
But I think I see what. Yeah, it's way smarter the way you're thinking of doing it. By doing it inline. But I think it's to use Swift parlance. I think it's and then like, you know, increment side table, as you called it.
Yep, that's how I see it. And I suppose that this code should actually live on this line. Okay.
I mean, you don't need, you can just get rid of this whole block. Oh no, sorry.
No. We actually need this. We can. It's here. Yeah, there.
Yeah,
when we
this
keep
block
this
you can-
score that changed, the rules for scoring has changed. Okay.
Yeah. Although we could keep this so that we have the answer to part 1 and part 2 for in our final script.
Yeah, I'm happy with that. I'm happy with making a copy as well. But anyway, so we will need to keep our side table, which I will call cards counts, which will start empty. And then when we get to this chunk, only if we have more than or one or more, not that it matters that much, but it goes here. I think it makes more sense if it goes there. Then what we want to do is do this logic that you proposed. So I'm going to paste it. And the way that you write this in Lua is very similar indeed. I think that the only difference may be that we do it this way. Lua in... I find that this website is great for like just syntax stuff.
Yeah, how does the for loop work?
We could just do it from. We could compile it.
You can use that if you can find it faster. Or did you already do it as I'm speaking?
No, now I'm typing the.
There, I found it.
I guess that's it.
Yep, that is.
I'll go back.
No, you did it. Yep, you had it. You had the syntax.
Oh, yeah?
Yep. That's what I found as well. See, it is for variable equals and then the range, and the range is inclusive. So in this case, 1 and 1 and no, not I plus. Oh, I see what you're doing.
I mean,
But then you don't start at 1. Then you start at.
No, sorry. I think this should be J equals I.
What
I
is
just-
I?
Not I, but what is we need the index, right? Yeah, we need to define I think. Or do we not? Is there a way around that?
Let's look at the results of gmatch, because maybe it also returns a counter.
Yeah, that would be nice. Otherwise, we could just keep I incremented.
Ooh, gee, wouldn't it be great if I could find this function, the documentation?
I was thinking about asking ChatGPT how to do the
Yeah, go ahead, do
type of
that.
syntax I want here.
Meanwhile, I've done it the basic way. I guess you want to enumerate.
Yep, you can get keys and... Oh, no, these are just matches.
That would be nice.
Yeah, I think that doing it the old way will be good enough for us. But we don't want to start at 0, right? We want to start at 1.
Yes.
And for my particular sensibilities, do you mind if I rename this from I to something like card number?
Sure. That makes
Okay.
sense.
And there, and there, and there, and there, and there. Yeah, that makes me happier. So now we have J going from card number plus 1. We don't want to, like, if you have 3 matches in card 2, we don't want to win another card 2. Plus card number plus we can lose the -1.
Yeah.
Plus our winning cards count do, and then cards count at J equals counter. Okay, but we also need to initialize this in case cards counts at J doesn't exist. So I'll say if is equal to nil. I think that's how you say it. Then it starts at 1.
Do we need to have it as card number? Because we're going to sum up the card numbers at the end. That's why we need it.
No.
Or what are we summing up at the end?
We are summing up the values in the cards counts.
Right. So it doesn't matter.
We need the card number because we need it here.
Right. That makes sense.
And I'm not sure what that's about, but it's probably a leftover. I'm happy with this. At the end, our card number will be 1 more than there are cards. So at the end, we need to go from 4 card number, or maybe let's use J equals card number up to the number of elements in cards counts. Or maybe even, how about that? How about this? We just go there, do, and then score part 2 is equal to 0, score part 2 plus equals cards counts at J.
We don't have plus equals, I guess.
Thank you.
That's an interesting way of doing the length of something, the hash.
Right?
Yeah,
And
so this is just going through all of them. Yeah.
we also need to say that to begin with, our cards counts at index 0 is equal to 1.
Why?
Because we do start with the card in our deck. That's our beginning. That's our initial stage. But we would not go... we would not win a card here. There's no card 0 to win us a card 1. So we just need to make sure that we count this in when starting. Does that make sense to you?
Not really, because aren't we going to mark it in this portion here? If we have a winning, like, we should mark our own one at this point as well. That's why I didn't start with the +1, I guess. Because you could just mark it there.
No, but we want, when we have our winners from card 1, we want to win cards 2, 3, 4, and so on. We don't want to win card 1 itself.
But we do as well, right? Unless I've misunderstood the problem. If you win your card, you both win your card, but you also need to mark the future cards.
No, so you start with at least one copy of each card. And card 1 has 4 numbers. So you win a copy of not card 1,
okay.
but 2, 3, 4, and 5.
Okay, I misunderstood. So yeah, winning your card has no relation as to whether you'll count your card or not.
Correct. What we are missing still is the fact that when we are keeping the score here, we don't want to just get the counts of the cards. We also... No, it's not that. Somewhere in here, we need to multiply by the cards counts of... where is it? Where is it? Where is it? We don't want to add 1. We want to add this. Jeez Louise, that's interesting.
Do we? Is that how it works?
Let's think about this, but I think
Let's
so.
go back to the problem. I'm not sure I understood that. Let me have a little read.
Okay, and there's still another problem that I'm gonna try and explain as you were reading, if you don't mind. The problem being that if we don't win any of, let's say in our example, we didn't win any of card 6, but we ran it, and we needed to keep track that it had 1 in there. So maybe what I want is to have this line here as well for that, like so. I think that does it.
I think it's this.
Which means that we don't actually need this bit. And besides, I had it wrong. I had it counting at 0. Silly old me, using 0 indexing. All right, so what have we here? You are adding J. Tell me more. You are adding like...
Isn't J what we want to add? Isn't it? So if you have 2 instances of 2, isn't that what we're adding up?
No, pick another number. If I have 2 instances of 4, how does that contribute to the final score? If I have 2 instances of 4, does it contribute 2? Does it contribute 4? Does it contribute 8?
Contributes 8.
I think not, because it says how many total scratch cards do you end up with, not what is the sum of the numbers of the scratch cards that you have seen along the way.
So it's just the total. So isn't it? So yeah, then I think +1 was correct. Why is it this?
Because when you are playing, let's say, card 2, and you found that it's going to give you copies of card 3, you don't want to just say, oh, I want to add 1 copy of card 3. No. I may have 3 copies, or no, that's impossible. I may have 2 copies of card 2. So I want to not add 1 to card 3. I want to add 2 to card 3, because I have ran each of my cards, and each of the cards is going to contribute 1 copy of card 3.
Yeah. Oh yeah, yeah. Sorry, it is a very confusing definition. You're right, though.
But it's lovely. I love this problem. It's one of the best so far. It really makes you think.
Yeah.
So yeah, this fixes the problem of we need to have at least one copy of each card. And this needs to appear there, and it does. And then this split already worked. This is it already worked, and then splitting on spaces already worked, and this is just summing things up. And then if we have at least one, then this is the score for the first part, and this is for J, which is going from card number +1 and card blah blah blah, and this is still necessary because we may be going ahead, and this is looks correct to me. This is incrementing card number, blah, blah, blah. Then we go from 0. Nope. We go from 1 up to the cards counts, and we keep the score that way. Yep. I like everything I see. I want to run this. How do you feel?
Let's run it.
Oh, but I want to use the input from the example. Wow, it didn't crash. And it gave us 30. Woo!
Oh, first time, Leandro.
Not me, us.
Us. Okay, but you're driving today.
I will indent this. It doesn't really matter. We are splitting on the column, but anyway. All right, I have a number.
All right, that looks correct to me.
That's the right answer, everyone! First try! That's what I'm talking about.
Very nice.
Very nice.
Yeah, I love that.
I love that. Okay, what did we learn today? We learned about Lua tables. We have used one as kind of a list, but maybe kind of as an associative array. It so happens that the associative array starts at 1, but anyway, that's kind of cool. And we have used it as a set, and the rest is just pretty much iterating over numbers in a clever way, right? There isn't a lot of Lua-specific bits, but it was fun. This is cute.
Yeah, this it was just like defining it in the problem. I think just like understanding the definition was tricky.
Indeed.
But I think you did it almost like in a dynamic programming way, where you're like taking account for the fact that you never need to look backwards and you're always building on the future. Building up the future values from what you've already pre-computed, which is cool.
I like this one. It tickles me in just the right spots. Let's take a look at the subreddit. And now that we are doing it in the evening, I'm sure that there will be lots of juicy answers. So this is day 4. And what is the theme for today? Yeah, today's theme ingredient is punch card perfection. Okay. What is this no golf? Do you try to make it as large as possible? I have no idea. Anyhow, Rust. No, we want to sort by best. Okay, Vim keystrokes. We have seen this. We have seen this yesterday. Last time it was interesting to understand the solution. So load your input, type the following, and your part 1 answer will appear. It is removing the card numbers. because it's replacing. And also, I'm reading ahead here, and this matches a whole word. I read the rest of their posts yesterday after the stream, and this matches a whole word. So that's probably just getting the numbers, I want to say. And this must be the end of the string, just like in Ruby, maybe. And
what was part 1 again? We needed to find out which ones are winning.
we needed to sum up the winning
And that's
numbers.
the power of 2.
But yeah, in powers of 2, correct. And then I want to see this in action.
How did they do that?
Ah, geez Louise. Well, they are just massaging the input with regular expressions so that in the end you will have just the winning numbers separated by pluses. Something like that, Just building up an expression and then running the expression, because the person is kind of doing this every day where they follow a design pattern, as they call it, which is to run an expression. There is some way of running an expression. I'm not sure what it looks like, but probably that's what this equal is about. Yeah. See?
Probably like in Vim you can,
Yeah. Jeez.
I mean, this is a full-time job, not just finding, working out how to do this in Vim, but curating the answer so that people can read it. So
Let's see the Python solution. You like Python, and let me guess.
I do.
They are gonna use that default dict thing because you can default dict to 1.
Yeah, that's coming.
Yaha!
Hey!
Called it. Removing.
See, the list the comprehension expression there is nice.
And then you can use set inclusion, set intersection, set intersection, right? Cool stuff.
Not union? Ah, intersection, yeah.
Intersection, because you want to see which of our numbers are in the winning numbers. And then the power of 2 trick. So this is part 1. That's okay. I want to see part 2.
And again, the default dict. No, that is part 2 there as well.
Wait, what?
That's a little for loop at the end on line 18.
So
That's
while
what
they
the
were
default
doing
dict
it,
comes in.
they were doing this bit. Oh yeah, we have seen this. We did it.
Yeah.
We did exactly that. Okay. Very impressed by how quickly you were able to grok the puzzle descriptions. I probably spent more time reading part 2 than you spent solving both puzzles, and even with me skipping the fluff.
Yeah. I feel that way. I feel like a lot of my time is like, what was the... Yeah. Understanding the cryptic problems took some time. But that was a very... Come on, you got to admit, that's very elegant Python. It does express it very cleanly there.
Yes. I do love this. For me, that's really cool. And the comprehension here, I still have my... I find it jarring that the 4 is at the end of the line. I would rather have it in the beginning, because I don't think about things in this way. I think like for x in blah, 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 do x transform into int.
Yeah.
But given that the line is so short, I have no problems parsing it, so I'm okay. It's just that if this gets a tiny bit longer, I get disoriented. Probably out of like a familiarity, but it is a very nice solution here.
Yeah.
And we will be using Python soon enough when the problems become too hard.
Yeah, I'm sure, exactly.
Then, okay. Another one.
Okay.
And this is gonna be different, I suppose.
Another Python one.
Okay.
So that map is the alternative to...
Yeah, no, this is the stuff we have seen.
Yeah, it's very similar, and it's also doing the same operation.
Yeah.
But you see the maps. That's the alternative to comprehensions, I suppose. Basically the same thing. The string.split and line.split thing.
Yeah.
So I think the benefit of map is that it creates an iterator. So
True.
you don't need to necessarily go through everything.
Okay, I will express another opinion. This is called point-free programming, in the sense that you are not giving the parameter name, you're just passing a high order function here. And when it's short, okay, I use that sometimes. As soon as it gets long enough and you start having to compose functions here, wow, it gets really insane really fast. I love naming parameters, even if it's something as silly as x. It just helps me.
Sorry, what do you mean? Do you mean the? Because I always forget which way round it is. Oh, you mean this?
Yeah.
Yeah.
To use some JavaScript here.
Yeah. 100%. Yeah, I understand that.
And then golf the solution to fit in this. Okay. Now I'm invested. Okay.
You would have thought he'd use a comprehension if he was golfing, but yeah.
Yeah.
You see, that's.
Okay.
I mean, you can put the 4 at the beginning of the line, I suppose.
Ooh, I love this. That is really cute.
Although I don't think that it's that cute because it creates a copy of whatever's there. Now, because it's an integer, it's copy by value. But if it was an array, they would be like references copied. And actually, I remember I was building for my dissertation some neural networks, but like some innovation on neural networks. And I was initializing the weights with like this kind of syntax, and it was creating duplicate references, and I couldn't understand why the hell my program was not working. Needless to say, I did do some cartwheels when I worked out what it was.
Well, you're saying that the 4 is at the beginning of the line, but is it really? It's at the end of this line. This is the expression.
No, I was talking about the line above.
Ah, that one. Okay.
It's a one-liner, so yeah.
Also,
yeah,
could
what
you
the
do
hell
this with list comprehension? Given that you have to do a modification in the list itself, the list that you're building?
What's he doing here? Yeah, I suppose you could do that in a list comprehension. You could just form the entire thing from that. That'd be kind of cool. But I guess it's not a default. You might not actually always. The reason he's had to initialize it, like normally with a comprehension, you have to initialize every value. Is it guaranteed that you will actually initialize every value?
I guess that's what this is about.
Yeah, it is. But it does look like you will initialize every value there because it's I and J. Oh no, it's +1. Yeah, so that is why he does that. Yeah, that makes sense. And that's why you couldn't do it in a comprehension.
Someone is happy to have gotten in the leaderboards.
Yay, congrats.
Yeah. I loved this esoteric programming language, Rockstar. This is what the program looks like. Where are the numbers? What the hell?
Wow, that's so funny. It must be, I mean, if you're a touch typist, like that must be one of the fastest programs to type. Because like I think it's all the characters which slow people down.
All the punctuation, right?
Yeah. Yeah, I'm gonna say yeah, especially.
Nothing clever today. Yeah, I'm trying to find something clever. I think that there is some mathematical underlying thing about the powers of 2 and stuff, but apparently not so much.
Yeah.
It's just doing this. We did this. Wait, how is the... Oh, it's using the map. Okay. It's cute that the default character for split is a space. That helps.
By the way, am I slowly convincing you that Copilot is useful for syntax that you don't know?
Was I ever unconvinced? Are you trying to convince me?
I don't know. I think I get the impression you're reluctant to use Copilot.
I can share some thoughts. When
Okay.
it comes to a language that I know, I find that, first of all, for bigger programs that really matter, I went to the wrong screen. For programs that really matter, most of the time I'm editing more than I am creating things, and I'm editing things that are like far apart in the code base sometimes. So I don't think that Copilot is really meant to solve that problem, which would be amazing because you're sometimes limited to like refactoring by renaming a variable and extracting functions and all of those things that an IDE can do. But if you want anything more clever than that, you are out of luck and you have to do it by hand. So that would be amazing if it could do that, but it's not there yet. When
What's
it comes,
an example of that?
huh?
What's an example of that? So like,
Oh, maybe I am using integers to represent time, and now time is too big. I need to use longs. The bug of the millennium, that kind of thing. It's
Yes.
trickier to do because it involves more logic. Like now that I have a longer number, I may have to operate on it differently and things like that. Just an example, but you know what I mean.
I guess what you mean is like sort of guiding you through like refactoring in multiple places at a time.
And I find that a
rather
type
than-
system helps me do that to some extent, but GitHub
Yeah.
Copilot is not really meant to do that. So, and then when it comes to languages that I know, it's mostly a matter of finding APIs and that sort of thing. And you have to read the documentation anyway. So just given a snippet of code in isolation doesn't help me much. Then when it comes to programming languages I don't know, I want to have the language under my fingers. I may copy and paste sparingly, but I want to type the programming language so that I actually eventually learn it better. There is even a book called Learn Something the Hard Way, and the something is like different programming languages. And one of the tenets, at least it was in the beginning, was that you're not supposed to copy and paste any example. You have to type everything from scratch because you want the muscle memory of typing in that language. And GitHub Copilot would take that away from me. So as a pedagogical tool, I was teaching today, right? I was at the coding school today, and I am seeing most people using either Copilot or ChatGPT or both. And from a pedagogical standpoint, I don't think it is the best, especially if you're learning, because then you're first of all not getting the language under your fingers, and second of all, you may have a hard time telling facts from when just GitHub Copilot is hallucinating, which happens, it happens. So I find that it's not really good for any of the things that I would want it for, and for the thing that I would like it for, it's not there. So yeah, that's why I ended up not using Copilot. Now, of course, this is not to say that if other people have different needs or if they have different opinions, more power to them. I love that GitHub Copilot exists. I have nothing against it, and I wish it gets better and better so that eventually I will use it as well because it will be doing the things that I want it to do. But we are not there yet. Those are my thoughts on GitHub Copilot. How does that sound? Do you think it makes sense?
Well, I think that confirms my suspicion that you are reluctant to use it. Yeah, I don't know about the learning code the hard way by typing it out. I think a lot of the code that I write, I read more code than I write. And a lot of the time I'm quickly parsing, whether things look correct or not. And I think it's the same when Copilot generates code. I'm reading the code and working out whether it's correct. I'm even rereading the code that I just wrote. So I think most of the time it's about reading the code, and if you can just tab through that stuff, then it gives you a pretty good, you're still basically doing the most of the work. And I think especially when you're learning a new language, like we're learning with Lua, for a lot of the basic things, like how do I iterate a loop from this to that, like from a programming standpoint, from a computer science standpoint, what you want it to do. You just don't know the exact syntax. And it took you quite a while to find the syntax and this kind of thing, which, like, it might be hallucinating, but it's quite easy to work out whether it is hallucinating. And there's certain things that you can learn to trust it on. You kind of like build a...
Oh, yeah. The hallucination comment was specifically directed at people who are beginners and you are not. I was talking about the people who are in a boot camp learning to code. They have never written code up to 9 weeks ago. And they are relying heavily on these tools. And I'm like, that's good. They're getting some stuff done. From a pedagogical standpoint, I would have done something different. Maybe I would have told students, perhaps don't use it during the bootcamp, or maybe something like that. I don't know. Anyway, it's also not a nice thing to say, don't use the tools that would help you, and I'm not sure.
Yeah. Also, I like your hot takes, so more of them.
More power to the people who want to do the things that people want to do. All right, so let's take a look at a couple more. Let's see if there is anything interesting. This is Perl. We have seen this before. Chomp. Regular.
We did. I don't think we saw the chomp.
No,
we saw the while.
Yeah, we saw that.
Oh, really? Okay, that's just me then.
Yeah, no, we saw this, and it means for each line, chomp is new. I have no idea what that is.
Oh, chomp is new.
Chomp is new.
Yeah, I didn't remember chomp. I guess chomp means like consume this line. I don't know. No, maybe not.
Okay, some parsing and was it silly to have used sets? It was silly to have used sets because we don't repeat numbers in our inputs. This person is using lists. Most solutions were using lists. I thought it was cool to use sets.
Yeah, or default dict, so it's kind of the same.
Using sets in Lua made it easier to find containment, because to see if an element exists in a list, maybe there is an auxiliary function in the table library that does that.
Yeah.
But using the keys made it very easy to check for containment.
Yeah.
Okay. So
show me what you mean, actually. Go back to our code just to clarify that.
So
how we use the sets.
If we had used the first suggestion, that was to use a list, essentially. So we would do winning numbers, that, and table.insert. If we had done that, then we would end up with a list that would read like position 0 equals some number, like 5, and position 1, or not 0, 1 and 2, and so on. But then later we would need to check, is 5 in my list? And then maybe there is something like table exists or whatever that would check if my table contains the value 5 as a value, but we would need some auxiliary function. Essentially it would be an array of numbers, and the numbers don't repeat, that's all right, but you would need to check containment in this array, which is annoying. But the way we did it, we end up with a table that looks like this. So checking for containment is straightforward because we just check, does the key exist?
Yeah. That makes sense. Also, I don't think we'd insert it into the global table. We would still have to have local tables. Well, because the original code was inserting it into a global table, and that would make it very difficult.
What did you say?
So here, I mean, the key thing is that the winning numbers and winning numbers is a local table, right?
Mm-hmm.
And the original code was inserting it into a global table, and that would have made it like impossible, maybe.
Okay, I see what you mean. And let me make sure that it didn't break anything. I didn't. Okay.
Cool.
Yeah, I think that we can call this a day. I think we succeeded. Another one in the bag.
Well done, man. Yeah, another one in the bag. Right, well, I look forward to day 5.
Yes, and I think we need to start using the programming languages we know.
Definitely.
Because I don't want to be here until midnight. By the way, what's your schedule tomorrow? Do you think you can do 10 p.m.?
Yeah, let's do it. We can do it again, yeah?
Okay, yeah, that's what's going to work for me as well, given the coding school. So I see you here tomorrow again at 10 p.m. And yeah, let's see what chat has to say.
Oh, yeah.
Chat says, fire, hi, and hello. Well, thank you, Nathan, Nod Was One, and Bo for joining us. And thanks, Star, for joining us as well. You're gone now, so bye. But thanks for joining us. And especially thank you, David. You are amazing.
Oh, thank you.
Tomorrow you are driving.
All right, well, okay. I'm excited for it.
All right. See you. Take care. Bye.
Steve, bye-bye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all will be back together for some more coding or talking or chilling. The next time I'll be streaming.